Good afternoon, everybody. Well, okay, you really are awake. It's kind of hard to tell with these lights the way they are. You know, the three of us are going to try to bring to life, I think, some of the things that the panel just talked about. It was quite encouraging to me to sit there and listen to them talk about it. And one of the things that came to my mind was a Thomas Edison quote. Most people miss opportunity because it's dressed in overalls and looks hard or looks like work. So, I thought about that and I thought, that's a little bit of what we're dealing with in AI right now. Maybe it's dressed in that black box, so it's a little different than that. Is it going to be hard? What do you do about skills? What do you do about trust, etc.? So we're going to unpack that for the next few minutes. I want to start, though, with the fact that it is about opportunity. Between now and 2030, AI will help drive $15.7 trillion of additional economic value. And that is for the businesses that leverage it. So this is about how do you unlock that value? How do you do things between predicting and shaping what those outcomes need to be in your business? How do you support the people that are doing the work in your businesses and in your processes? Lots of the discussion has been here about automation of the decisions, the processes, the experiences. And then I would tell you it's also about reimagining new business models and how to bring those to life. So that's the opportunity. And you all have a position such that you can help capture that opportunity. So don't miss it. Don't look at it as being in overalls. And thousands, frankly, are already doing it. So I wanted to share some use cases. These happen to be use cases we're doing with Watson, which is IBM's brand for artificial intelligence and the technology that we do there. We've had over 20,000 engagements across 20 industries around the world. But I'd like to just pick a few to highlight. One, Royal Bank of Scotland. So Royal Bank of Scotland is really using AI for customer care, both self-service and agent assist, as well as for employee care. So how do you do internal help desk? How do you do onboarding? How do you do all those things that are so critical to your employee base as well? And it's all about satisfaction that leads to loyalty of the customers and return business, and it's about call containment. So that's one kind of example. I was actually going to talk about KPMG's tax work until I heard Steve Rainey talk about it. So you heard that. That's a completely different way of helping expand the expertise that exists and using it to do some of that mundane work that then allows us as individuals to scale. I thought Fifth Third Bank would be an interesting one to highlight because a lot of times people will say to me, okay, Beth, that's fine and good, but in what you've packaged with Watson, you're doing my particular use case. In this particular case, Fifth Third Bank was really focused on customer analysis, so marketing analysis, etc. And they wanted to leverage open source technologies and all sorts of AI, from the statistical models to machine learning to deep learning. So they wanted this full spectrum. But to do that, it was important to focus in on, well, wait a minute, how do I get governance around the data and these new objects that I'm dealing with, these new things called models? And how do I also have the environment by which that the people that are creating those, building them, testing them, evaluating them, deploying them, etc., have an environment that fits into the rest of my business process so we can support it at scale? And then the other one I thought might be of interest, just to throw in an IoT sensors kind of thing, is KIST Europe. So this is really about manufacturing lines. So if we think of manufacturing lines today, all aspects along those lines have smart components. So various things are happening along the way. But even so, there ends up to be situations where people have a lot of scrap that frankly might not really be scrap. So what have they done? They have focused in on building a model that helps the scales along the way to understand if their measurements, they have to be quite precise, if those measurements are accurate or not. So in this kind of environment, a forklift going alongside the manufacturing line could cause the scale to misread. That happens, it runs along, it gets scrapped, or worse yet, it comes out as quality and then causes a problem later. So what they've done is said, okay, the scales that are in line have to now be smart enough to understand this and understand that the measure they just took is not accurate. They need to take another measurement right there in the line where it is. These are all examples of putting AI to work. And I agree with part of what the panel said earlier. It really is now about putting it to work in the processes that we all live in and operate, and our businesses operate in and day out. Now, to take advantage of your part of that big opportunity, that 16 trillion that everybody's working on, you need a thoughtful and prescriptive approach that is about building and scaling AI. And that starts with data. We know 80% of the data that businesses are working with is actually inside of your businesses. Yes, you've got external stuff, etc., but you have this huge asset. So it starts with data, but that data is diverse. And frankly, the data you'll have tomorrow, you don't even think of today about what its diversity may be. So it is about being able to collect this and then make it accessible for anybody from your data engineers all the way to your knowledge workers in a simple way. Now, once that's taken care of, it's then about how do you prepare it? How do you organize it? How do you make sure it complies with your policy and compliance? How do you catalog it for the business? And then it's about now, well, I got to analyze it. And I may be analyzing it all the way from some of those simple visualizations and dashboards all the way to deep learning models. And a combination of that, and I've got to be able to do that in a trusted environment, and then infuse that inside of my workflows, my processes, etc., all in a modern hybrid cloud environment where data and analytics is going to be in different public clouds, on-premise, etc. Simple. So we call this the AI ladder because we think it's a way for people to be able to visualize what we're talking about in this very thoughtful and prescriptive approach because it's all about scaling. Now, I mentioned operationalizing it. You know, this is about putting it in those workflows, being sure that individuals, employees have access to it in the processes and the things that they do. So this is about it being wherever that data is, inside those workflows. But then it's about runtime in production, not just what can be evaluated in the test, but in production. Tracing the results of the models, the decisions that are being made. How does that get traced and connected back to what your business measures are? How do you end up then having a continuous feedback, learning loop, and have the governance and process around that so that you actually know what's happening and that you have accountability and traceability from the decisions that are made, the model versions that are used, the data that was used to train it, etc. All with the ability to understand and detect bias at runtime in production to mitigate that bias and be able to explain the decisions that black box made in terms that tie back to your business context. And that's what we've been doing in particular in Watson OpenScale, is to help people be able to do that. So now I'll bring it back to trust. I do believe that trust is a competitive differentiator today in so many ways. We published our principles for trust and transparency They are the purpose of AI is to augment human intelligence. Your data is yours, and the insights from that should be yours and not mixed in with everybody else's. So how is that done? And then these systems, these AI systems, must be transparent and explainable. You heard Martin talk about it, and Kelly's going to go into more detail as well about how the different elements come about in fairness, explainability, robustness of those models, and ultimately accountability through traceability and auditability. So with that, Kelly?
Yeah. Great, thanks, Beth. So I personally believe, as I'm sure Swami and Beth and many of you I'm sure are convinced, that AI is a game changer. So we're seeing AI transform the way that we interact through social networking, through things like LinkedIn, dating apps. We're seeing it recommend how we can get to work and what's the best route to avoid traffic, especially in Chicago. We're seeing it recommend TV shows when we watch Netflix on what shows are going to match our best preferences. And when I walk out of the house each morning, Alexa's reminding me, hey, Kelly, you need to grab an umbrella because it's going to rain in Chicago again today. So it's very obvious that the capability for AI is happening. But I think for many, AI is still a concept of a black box. And so what we need to understand is that AI is really not all that different than us as humans. And what we do when we build an AI system is we train AI to think, mimic, reason, infer, just as we as humans do. So let's take, for an example, 3 apples. One apple we eat, it's red, it's sweet, it's a fruit. We have to train the system the attributes of that apple in order for it to be able to understand and decide what the outcome is. The picture of an Apple logo, right, which tells us brand reputation, technology, my iPhone. And then the last apple, which arguably is very tricky, it has no probably true Apple aspects to it other than it's Apple Jacks. And we have to train the system that it's associated with sweetness, with breakfast, and with milk. So why does this matter, though? Why is this important? Why am I talking about apples and Apple Jacks? And it's important because when we train systems to behave like humans do, there are net new things and unique risk considerations that we need to be thinking about. And those are the 4 trust imperatives that Beth was talking about. So the first one being around integrity. So she mentioned it's all about the data, right? So the provenance of data, the lineage of data, how data's changed. This is the data that we're changing our system on, that it will decide, is it an apple or is it the Apple logo? Explainability. So how do we explain in business terms to our regulators, to our customers, that AI is reaching the conclusion that we want it to? Resiliency. So this is all about technical robustness. I think a lot of us have heard terms like adversarial attacks. The technical soundness of the AI solution that we're creating. And then lastly, bias, which we can all argue is the hottest topic in the news today and is what's likely getting a lot of our clients in trouble legally, right? So how do we prevent unintended and unwanted bias? And how do we ingest it with the right bias that we may need? So how many of you this morning woke up and had milk, whether it was a glass of milk, maybe if you're a kid, or milk in your coffee? So every morning we wake up, right, and I pour milk in my coffee, and I take my milk carton out of the fridge, and I pour a little milk into my coffee cup. And I believe 9 times out of 10, or probably most times, that milk that I'm drinking is okay to drink. I trust, or furthermore, I perceive that the expiration date on that milk carton is accurate. But we're living in a world that is rapidly changing and transforming, and perceived trust to our end consumers is no longer enough. We need to move from this concept of perceived trust into what we call technical trust, which is really how do we instill and embed trust into the design of our AI systems, and how do we operationalize that trust? And this is a huge driver for companies that are implementing AI and trying to solve the black box concept, is we need to instill confidence and trust in our consumers. And our consumers are demanding this. So they're asking for instant gratification. They're asking for real-time feedback. They're providing us their data, and they want to believe and know and understand that when they give you their data, that they can trust in the platform that they're providing you. So let's take a real-life use case example and kind of break this down and see how we actually start to think about embedding technical trust into AI. So imagine that I am responsible for 2.5 million citizens. I'm in a city that has 15 train stations, 5 metro routes, a thriving port and ferry operation, an international airport, brownie points if anyone can guess the city. But the city has 4.5 million visitors a day, and 4.5 million visitors annually, and 16 million visitors that took day trips to this city in the past year. And why is this important? If I'm the CTO of this city, the city of Amsterdam, I'm responsible for the digital rights of my citizens, and that the algorithms and machine learning that I'm deploying in my services and programs as part of the city solutioning, that I provide transparency and fairness to my citizens. This is the problem that we've been recently faced with the city of Amsterdam when they came to us and they said, we use AI today in our sanitation program. And what AI does is when people complain about sanitation and the safety of the city, we use AI to determine where should we deploy resources and what should those resources look like. And you can imagine that people that live in higher income areas with better access to information, or that just simply want their area to be cleaner, might file more complaints than people in lower income areas. So what we did is we started to say, let's deploy KPMG's AI and control governance process, those 4 trust imperatives. Let's start to prove out fairness. Let's start to prove out explainability. And when we do that, we start to instill in the design of AI this concept of technical trust, and we begin to inch a little bit closer to getting comfortable and trusting AI, or having AI that we believe is in control. And with that, I'm going to hand it over to Swami, and we'll start to talk about how does this actually look like when we implement this governance construct.
Thanks, Kelly. So imagine a scenario like this. You are invited to a meeting with your management, and there is a series of questions you're getting asked, and eventually a mandate given to you. The questions are as follows. How do we know what our AI models are doing? Are our models biased against a particular segment? How do we know our brand reputation is at or not at stake? How do we know we are using data sources that we are not supposed to be using? And you scratch your head and stand there. And you're also given mandates, like, for example, what you see on the screen, like from the state of New York, about how insurers can use and not do certain things. So, for example, insurance companies should not be using external data sources in a predictive model or an algorithm where you cannot trace the lineage of the data source. Or the models by themselves cannot use certain kind of features like disability or age or gender and be whatnot. And also things like if you are using a model to make a decision, which could be like deciding the premium on your underwriting policy, you should be in a position to explain those results. So as you walk out of this room in this kind of scenario, how do you operationalize this? So let's kind of get to the theme of tomorrow. So how do you do this? How is the how? How do you go about operationalizing this trust, and what are the kinds of things you need to think about? And Beth and Kelly, right, talked about the trust anchors, and KPMG has these 4 trust anchors as we talk about. And as we look at each one of these, what I would like to do is talk about what do you have to do in order for you to realize or have a framework using which you can start to understand what is your AI doing and everything that is associated with it. So if we start with integrity, it's all about what did I do to build my models? So you need to be able to understand, starting from the raw data to when it became labeled ground truth, if you're taking a supervised approach, to how was the model trained, who trained the model, what was the metrics the model kind of eventually turned out to be, and that whole provenance or lineage. And also understand all of the actions that were taken from start to finish for the model to be turned on into production and being used by applications and processes. So you need to be able to have a system that can track all of that and be able to give you visibility into what actually transpired. Now, the job doesn't end there for integrity. It's also about, once you have deployed the models, how do you understand in a very continuous basis, how are my models performing? You may have built a model to predict if my customers are going to churn, but how do you know if it is still valid, how it is not drifting away from what it was built for? So the ability to continuously monitor the models for things like metrics, including F1 scores or precision or recall or concept drift, you can use tools like Watson OpenScale to be able to do that. So integrity is all about trying to understand how the models got built and how do I keep track of what it is doing. Then explainability, the name says it all. The model is making a decision, and end of the day, I always say this, mere mortals should understand that. It's not about stat and math, right? It should be about how can I understand the decision the model is making, and most importantly, what are the key features that the model is using to come to a decision, if it is a structured data model, or if it is an unstructured data like an image, which regions in the image is making it to be detected as a cat or a dog, or if it is text, which words are contributing it to be classified or extracted in a particular way. So explainability is critical. There are techniques and tools available, including Lyman Sharp, which you could use to go do that. There is also what I call a trade-off that you're going to come up, which is the explainability versus accuracy trade-off, which is, of course, nonlinear models or nonlinear techniques like deep learning or neural networks would let you have a higher degree of accuracy. But if explainability is of more importance because of various factors, including regulations, go back to the one we were talking about earlier, then you may have to have a trade-off. Should I use a linear model like support vector machines versus go to a deep learning model? But still, there are techniques that are emerging even in the deep learning space where you can start to do explainability using things like random sampling of inputs or network layer activations and whatnot, which you have to keep track of. Then fairness, which is about finding bias. So one thing is to say I should not be biased, but how? How do you go about taking the data, taking the model that is learning the data and making sure there is no bias? It's about taking the data and being able to use techniques to understand if there is a bias or imbalance. And you could ask me, how do I measure bias? So there are, again, tools and techniques available, including equal parity, or it could be around various techniques that you can understand if there is bias against a particular feature, like an age or gender, and within age, are my age groups 18 to 24 biased with respect to ages 45 and above. So being able to understand at that level and quantify the bias is one thing you need to be able to do. And also, most importantly, once you've deployed the model, bias can start to creep in because the model is going to be continuously learning. If you have set up all the feedback loop and everything in place, of course, you need to govern the feedback, but how do you continuously monitor the feedback that is coming in and making sure there is no bias that is creeping into the system, and also being able to get alerted and saying, hey, today I received 1,000 requests, out of which I'm seeing there is a bias towards a particular feature or a particular age group, and then you'll be able to act on it. Then last but not least, resiliency, which is about how do I protect the models against adversarial attacks, how do I test for it, and how do I protect the endpoints, the models that are served up as APIs and whatnot, simulating and making sure it cannot be compromised and whatnot. So these are the things that you need to take care of, right, as you go and operationalize this trusted framework. But in the end, right, as you start to put these to life, there are various things that you may start to do, including providing that dashboard for the management where you may never have to be invited into a meeting. They can look at the dashboard and get full visibility into what is going on with my AI, or also being able to understand how my models have been working and how they have been assessed for various controls and risks and whatnot, and with respect to all the 4 trust pillars we've been talking about. So with that, thanks for the time. We have more information about what we talked about in the demo pit outside. So if you could join us, we'd love to go into more detail. But thanks, everybody.